21x minus 15y. You want to factor that. So what's the first thing you have to find? GCF. So what's the GCF? 3. That's the largest common factor they have in both, right? So 3 goes into 21 and 3 goes into 15. What about your variables? Do you have any variables that's going to be part of your GCF? No, because we learned that in order for the variables to be part of the GCF, it has to be in every term. Okay? And it's not. So the GCF is 3. Now, once you find the GCF, remember the steps right here, using the greatest common factor. So we found the GCF. The GCF is what in this problem? 3. All right, so now we're going to rewrite each term as a product. So remember, factors. Those things you're multiplying together are called factors. So one of your factors is going to be the GCF, right? Okay, so we're going to put that in front. So the idea that distributive property. So that 3 is going to go out in front. So he's going to say equals 3. And then you're going to have some terms inside that parentheses. The number of terms inside the parentheses should equal the number of terms you started out with. How many terms are in this polynomial?
2.
So how many terms should be in this parentheses? 2. And then just use a distributive property in your mind to figure out what goes in here. So 3 times what's 21x? 7x minus, and then 3 times what? 15y? 5y. So there's your answer. So you factored this polynomial. You wrote it as a product. And you used the greatest common factor. You used the greatest. All right, number 2. Suppose you had 7x to the 5th minus 2y to, let's say 2x, excuse me. 2x to the 3rd power. 7x to the 5th minus 2x to the 3rd. What do you think the GCF is here?
1 to the 3rd.
Okay, so in terms of 7 and 2, the GCF is 1, but is 1 the GCF though? No. Because what do you notice about those two terms? They both have x's in it, so my GCF has to contain the variable x. All right. Now remember, we talked about the fact that when dealing with variables, you look at which exponent?
The lowest.
The smallest. Okay. You're not going to use x to the 5th as a GCF because x to the 5th does not go into x to the 3rd. There's not enough x's there. There's how many factors of x here? 3. You don't have enough. But x to the 3rd will go into x to the 5th because how many factors of x to the 5th do you have? 5. And then 3 of those will reduce with the 3 that are here. Okay? All right, so the GCF is x to the 3rd. So you're going to say the GCF times some polynomial that I'm going to put inside that parentheses. You have to remember some things from last semester. The product rule from last semester. So remember the product rule from last semester stated something like if you multiply like bases, what do you do with the exponents? You add exponents. So if you had x to the 8th times x to the 4th, then that's x to what power? The what? 12. 8 plus 4 is 12. So that's the idea you're going to use here. So x to the 3rd times what is 7x to the 5th?
1x.
Not 1x. You got to say 7, okay? 7. There's a 7 there. You need a 7. 7x to what power? The 2nd. X cubed times x squared is x to the 5th power. When you multiply like bases, you add exponents. 3 plus 2 is 5. Minus, and then what's going to go here?
2.
Just 2, right? Because you already have the x cubed. X cubed times what's 2x cubed? 2. All right, so there's your answer there. Number 3. All right, so what is number 3? You had, let's say, was 14x minus 21y plus 7. What's the GCF?
7.
7. So it'll be 7 times. All right, what polynomial will be inside that parenthesis? 7 times what? 14x.
2x.
2x. Minus 7 times what's 21y? 3y, and then plus what? 7 times 7 is not 7. 1. Okay, so you see how he said 7, and then you need to quickly check it, right? So he said 7. If you put 7 right here, and when you check it, what's 7 times 7? 49. Obviously, that's not true. Okay, so you see, you can always use distributive property to help you to get the right answer. All right, number 4. All right, 4, suppose you had 15x cubed plus 9x squared. What's the GCF?
3x2.
3. Okay, don't say 3x2. You correct yourself. You said 3x to the second, right? Or 3x squared. All right. So 3x squared is the GCF. I'm going to go ahead and write that GCF down like this. All right. So when you find the GCF, you're going to say the GCF times that polynomial. So it's 3x squared times, all right, 3x squared times what's 15x cubed?
5.
Just 5?
X.
5x.
5x.
X squared times x is x cubed. It's not just 5, because 3x squared times 5 is 15x squared. You wanted a 15x cubed. Plus 3x squared times what's 9x squared?
3.
3. 3. All right, number 5. You have 12x squared y minus 42xy cubed plus 48x cubed y. So 12x squared y minus 42xy cubed plus 48x cubed y. All right, so you have 3 terms. Let's talk about the GCF. Start with the coefficients first. You have 12. Don't worry about the negative, although this is a negative 42. Just look at 42. 12, 42, and 48. What do you think the GCF is? 3?
6.
6?
Oh, yeah, 6.
Okay. And you can always check yourself. 6 times 2 is 12, right? 6 times what? 42? 7. 6 times what? 48? 8. And so the 2, the 7, and the 8, they have nothing in common besides 1, right? Okay, so it is 6. GCF is 6 so far, right? What about your variable x's? Will x be part of my GCF? Yes,
Yes.
because there's an x in every term.
So it'll be just x, though.
Right, just x, the one with the smallest exponent. All right. What about your y's?
Just y.
Just y. All right, so my GCF is 6xy. So you're going to say 6xy times, and then 3 things need to be inside the parentheses. And then use the distributive property and the product rule to help you with this. 6 times what is 12? Let's do that first. 2. So I know I'm going to have a 2 here. All right, now I have xy. Xy times what is x squared y? Just x, right? Just x, because I want to end up with a y already taking out a y. So if you put a y there, what's y times y? Y squared. So you know that you made an error. So it's just 12x. Minus 6 times what? 42? 7. But what's
Y squared.
y squared? Very good. Okay? Because x times x is x. X times, there's no x there, right? I didn't mean x times x is x. X times 1 is x. Y times y squared is what? Y cubed. Okay? Plus 6 times what? 48?
8.
8. And then x to what power?
Squared.
Squared. Do I need any y's?
No.
Nope. Okay, if you put a y, let's say you made a mistake and put a y. Check yourself. Y times y is what?
Y squared.
But what do I want?
Y.
Y. So I don't need a y. Okay? So always check yourself. And so there's your answer.
God bless you.
Okay, number 6. Let's suppose you had, all right, 13a cubed b squared plus 39a squared b minus 26ab to the fourth. So 13a cubed b squared plus 39a squared b minus 26ab to the fourth. 13. What else?
A.
A, okay. What else? B.
AB.
Okay. 13ab. All right, so that's your GCF. So you're going to say 13ab times, all right, we got to figure out what goes inside the parentheses. 13ab times what is 13a cubed b squared?
A squared B.
A squared b. If you thought something else, check yourself and see if it makes any sense. A times a squared is a cubed. B times b is b squared. Plus 13 times what is 13ab times what is 39a squared b?
3A.
3a. Yes, 3a. 13 times 3 is 39. A times a is a squared. And I just needed to take out a b and I'm done. Minus, and then what?
2B
2b,
squared.
nope,
Cubed.
cubed. Not squared, because b times b squared is b to the third, but I wanted b to the fourth. Okay. All right. Okay, now let's look at number 7. All right, number 7 is that the way it's going to look, number 7, you're going to see that structure when we do grouping in a little while. So we're going to do grouping in a little while, but it's going to look like this. So look at number 7. So number 7, you have x times x plus 5 minus 2 times x plus 5. All right. So in a little while, you're going to see this, the way this thing looks, come up again. But if you look at what you have this product right here. So I'm going to underline it right here. This product, right? So if I cover this part up, what are the factors of this that I have? What's the first factor you see? There's no x squared here.
5.
Okay, so last time we talked about factors, right? Last time we talked about factors. I'm getting all kinds of things. X squared, 5.
We talk about factors, not terms.
You're talking about factors. Factors are separated by the multiplication symbol, right? Read this to me. X times x plus 5. So tell me what's one of your factors? X. What's the other factor?
X plus 5.
X plus 5. Okay. If I cover this part up and underline this, and now really this negative goes with it, but I'm just going to cover it up right now. What are the factors here? 2 and what? X plus 5. All right. Now, those two things I have underlined, what factor do they have in common? X plus 5. Okay. So now what you're going to do, just like you did here, what's the GCF here?
X plus 5.
X plus 5. So you're going to take out the x plus 5. So you're going to say x plus 5 in parentheses, just like this, times, all right. Now, I put a lot of space here. You don't need all that space. So x plus 5 times, all right, just like you did here, you're going to say x plus 5 times what is this that I have underlined? X. Minus. And then x plus 5 times what is this that I have here? What do I need?
Minus 2.
2. Minus 2. So there's your answer. So the answer is x plus 5 times x minus 2. X plus 5 times x minus 2.
Can you do that for all, because basically, just, that's the GCF, there it is right there, and then you can look at the x minus 2.
Yeah, but it's the same idea as here. You're saying x plus 5 times what is this, and x plus 5 times what's this, using the idea of the distributive property. You need, in your mind, continue using distributive property. So if we look at number 8, we have y times x squared minus 3 plus 4 times x squared minus 3. So we're about to see something like this, so you need to recognize that this structure, the way it's written, is that you're going to group this 2 together and this 2 together. So you have this product. You see a product here, right?
Yes.
What are the factors? Y and what? X squared minus 3. Over here, what do you see as the factors? What are your factors? What's one of them?
4.
4, and what's the other? X squared minus 3. Yeah, they're both 3's. Did I say something that they have in common?
Yes, x squared.
X squared minus 3, so that's your GCF. So you're going to rewrite the problem as the GCF. Remember we said, take out the GCF. So it'll be the GCF. What's my GCF?
X squared minus 3.
In parentheses times, and then what's left? Y plus 4. So if you just kind of covering this part up, you have y and then what? Plus 4. And if I distribute, look, it makes sense because if I distribute this right here, x squared minus 3 times y, isn't that this right here? Y times x squared minus 3? Yes or no?
Yes.
Yes. Okay, and then plus, and then if I distribute that, isn't that 4 times this? Okay. So it's the idea of the distributive property. And you're done. There's your answer.
So in this one, we have to put the GCF in parentheses.
Yes, because if you did not, mathematically, okay, she's saying, did we have to put the GCF in parentheses? The answer is yes. Because if you didn't, this is what you would write. Mathematically, using the order of operations, what is being multiplied by y plus 4? No, it's not. Negative 3 only. That means this. That is different than this. Okay? So yes, you do have to put the parentheses around here. Okay? All right. So that is not the same as this. Those are two different things. All right, number 9. Suppose you had x times x minus 7 plus, all right, now you're going to see some things like this I'm about to write, x minus 7. Okay? You're going to see something like this when you do the grouping in a little while. Okay, so what are the, let's get out of here. What are the factors you see in that first part? X is one of them. What's the other?
X minus 7.
X minus 7. All right, so I agree with that. Over here, though, what's the only factor you see? That you see? X minus 7. Okay, but then you may say, well, in the ones we did earlier, in front of the parentheses, there was an X here, there was a minus 2 here, there was a Y here, there was a positive 4 here, there's an X there. So you see the commonality among those? But then you come here and you say, well, I don't see anything. Well, yeah, you do. You just don't say it. It's a 1. It's understood to be a 1. Okay? All right. So if you need to rewrite it. You would say this. X minus 7 plus 1 times x minus 7, right? Okay. So that's the way I would rewrite it. You're going to see that as you do some of these problems. Okay, so what's your GCF then? X minus 7. GCF is x minus 7. So I'm going to take the GCF, which is x minus 7, and you have to put in parentheses, right? Yeah. Okay. Times, all right, if I cover the x minus 7 times what will give me this back? X plus 1. Very good. 1. So x plus 1. So x minus 7 times 1 is this right here, isn't it? Okay. So there's your answer there. So you're going to see this idea in a little while. It's not difficult. All right, now there is a problem in Math Lab, and I think I have one in the worksheet like this. So as you look like this one, 1/3 x to the 7th plus 4/3 x to the 5th minus 7/3 x to the 9th. So you have fractions this time. So there's one in my Math Lab, so I did put one in the worksheet, so you'll get at least that on my Math Lab. And by the way, when's my Math Lab due?
Right.
Yeah, and so I send email after email after email, and y'all just email me back and say I'm not doing it.
You be killing my text messages.
I'm not doing it.
I took those notifications.
Yeah, you can always turn the notifications off.
It was like
Anytime I
91
change-
days. I was like, oh.
Anytime I change anything, it notifies you. So turn them off. Just make sure you check my math lab at least once a day. Not my math lab, I meant Canvas at least once a day. All right, so let's start with the variables first. In terms of the variables, what's the GCF?
X5.
Okay, she's saying the same thing as you. What did I
X to the
tell you
fifth.
about? All right, girl. You don't say X5. I have no idea what that is. X5. Is that like Xbox? All right, X to the 5th. All right, let's talk about the fractions. The good thing about this one is that the denominators are all the same, and the one in your worksheet be the same. All right, so you have so far that the GCF is going to contain X to the 5th, right?
Right.
Okay, so hold on.
Yeah.
Oh, Oh, I don't think so. All right. So best thing to do here is, first of all, look at the numerators, 1, 4, and 7. What, in terms of 1, 4, and 7, what's the GCF of 1, 4, and 7? 1. Okay, now you notice all the numbers are the same, right?
Yeah.
So you can take out, we said 1 of 1, 4, and 7, so it'll be 1/3. 1/3. So you GCF will be 1/3 X to the 5th. Okay? So it will be 1/3 X to the 5th times. All right, now let's talk about what goes in here. 1/3 X to the 5th times what is 1/3 X to the 7th?
X squared.
X squared. Good. 1/3 X to the 5th times what is 4/3 X to the 5th? 4. What'd you say? 4, right? Because what's 4 times a third? 4/3, which is what you wanted. Minus, and then 1/3 X to the 5th times what is 7/3 X to the 9th? 7x to the what? 4th. And there's your answer. Okay, that was number 10. All right, now, so that was the part on the GCF, okay? That was the part on the GCF. Okay? All right, now,